Let's do some kinematics. We'll go through 12 questions in this video. How far will a car travel if it accelerates at a constant 3 meters per second squared for 8 seconds? How high does a cat jump if its initial velocity is 5 meters per second? How do we use trigonometry to find out the maximum height of a projectile launched at an angle? Keep watching, find out. Let's solve our first problem. A squirrel jumps from a branch horizontally at a speed of 3.0 meters per second and lands on the next branch after 1.5 seconds. How far away was the branch? The first step in solving a problem is to look for the variables that we have been given. We have been given a speed or velocity which has the symbol v. So v is equal to 3.0 meters per second. And we have also been given time which has the symbol t. So t is equal to 1.5 seconds. And then the second step is to determine which variable we have been asked to find. The variable we have been asked to find is distance, or d. So d is equal to question mark, and we want that in meters. When we are solving problems in PHSI191, you can usually use speed and velocity interchangeably as long as distance and displacement are the same. And usually they are. Going back to the first problem, we have been given two variables, velocity and time, and we have been asked to find distance. And they have the symbols d, v, and t. So now we come to the third step, which is looking for the equation on our cheat sheet that has all three variables on it. The equation is d equals vt, or distance equals velocity multiplied by time. And now for our final step. We simply substitute our values for the variables. D is equal to 3 times 1.5. If we enter the numbers into the calculator, 3 times 1.5, then we get an answer of 4.5 meters. Now on to our second question. A man jogs in a straight line with a speed of 3.2 meters per second for 10 minutes. How far did he run in meters? First, look for the variables we have been given. Speed, aka velocity, so v is equal to 3.2 meters per second. Time, 10 minutes. Hold up. What units have we been given for time? Minutes. We have to convert this into seconds. Otherwise, we're going to get the wrong answer. So we're going to convert 10 minutes into seconds. There are 60 seconds in 1 minute. Simply multiply 10 by 60 in order to convert it into seconds. Our time t is equal to 600 seconds. If we had been given hours, then you simply multiply the number of hours by 3,600, since there are 60 seconds in a minute and 60 minutes in an hour. Second step, what variable have we been asked to find? We need to find the distance, or d, and we want to find it in meters. So d is equal to question mark, and that's going to be in meters. Third step, again we look for the equation that has all three variables. In this case, we can use the same equation as the last problem. So that's d equals vt. Fourth step, substitute our values for the variables. D is equal to 3.2 times 600. Let's enter that into the calculator. 3.2 times 600. That gives us 1,920. We rounded to two significant figures since the variables we were given only had two significant figures. And the answer is 1900. Question 3. A girl runs down a straight road and travels 200 meters in 26 seconds. What was her average velocity in meters per second? Step 1. Find the variables that we have been given. Distance, so d is equal to 200 meters. Time, so t is equal to 26 seconds. Step 2. What variable have we been asked to find? The question wants us to find velocity, or v, in meters per second. The average part just pertains to the fact that she may not have been going at one constant velocity during the 26 seconds. However, we just want to find the average velocity based on the distance that she traveled. Step 3. Look for the equation that has all of our variables. So our variables are d, v, and t. Again, it is the same equation, but we need to rearrange it for v this time. To get v on its own, we would divide both sides by t, and that will take it to the other side. We can also use the triangle method that we learned in the intro maths video. With the triangle method, we want v on its own, so we're going to group the other two variables, and we see that d is over t. So that means that v will equal d over t. Simple. Step 4. We substitute our values. V is equal to 200 divided by 26. We'll enter that into our calculator, 200 divided by 26, and we get an answer of 7.6923. Round that to two significant figures, and the answer is 7.7 meters per second. Question 4. A car is traveling at a constant velocity of 100 kilometers per hour. How long does it take to cover a distance of 200 meters in seconds? Step 1. What are the variables that we have been given? We have been given velocity, or v, which is 100 kilometers per hour. Stop right there. Did you notice that we have been given the velocity in kilometers per hour? We need velocity to be in meters per second. Otherwise, we will get the wrong answer. So let's do that now. To turn kilometers per hour into meters per second, we simply divide by 3.6. This is because 1 kilometer over 1 hour is equal to 1,000 meters over 3,600 seconds. 1,000 over 3,600 simplified is 1 divided by 3.6. If we divide 100 by 3.6, we get an answer of 27.777777777778. It just keeps going, but we have to cut it off somewhere. So let's write down v is equal to 27.778 meters per second. Notice how I wrote down 5 significant figures, 1, 2, 3, 4, 5. When doing intermediate calculations, I would recommend using 5 significant figures, as this ensures an accurate final answer while not being too slow. If we had rounded this to 2 significant figures, so 28 meters per second, and used this in our calculation, then we would get the wrong answer, as you will see later on. The second variable that we have been given is distance, so d is equal to 200 meters. Step 2. What is the variable that we want to find? We want to find time, or t, and we want the answer in seconds. So t is equal to question mark in seconds. Step 3. Find the equation that has all of our variables. Again, this will be the same equation, d equals vt, but we need to rearrange it for t. To do this, we simply divide both sides by v to get t on its own. Or we can use the triangle method. We want t on its own, so we'll group the other two variables, and we see that d is over v. So t will equal d over v. Note that you can have rearrangements written down on your cheat sheet so that you don't have to rearrange them. However, this will take up more valuable space, so it is useful to be able to rearrange simple equations. Step 4. We substitute the values. So t is equal to 200 divided by 27.778. If we plug that into the calculator, 200 divided by 27.778, we get an answer of 7.1999424. If we round that to 2 significant figures, our answer is 7.2. Now going back to what we said earlier, if we had rounded 27.778 to 28, then 200 divided by 28 is 7.14, which rounds down to 7.1 and gives you an incorrect answer. Question 5. A sprinter goes from rest to a top speed of 7.0 meters per second in 5 seconds. What was his average acceleration in meters per second squared? Step 1. What variables have we been given? We have been given 2 velocities, initial velocity and final velocity. The initial velocity, or vi, is equal to 0 meters per second because he is starting from rest. And the final velocity, or vf, is equal to 7.0 meters per second. If we have initial velocity and final velocity, we can calculate the delta V, or change in velocity. The equation for delta V is equal to Vf minus Vi. Delta V equals 7 minus 0, so delta V is equal to 7.0 meters per second. We also have time, so t is equal to 5 seconds. Step 2. What variable do we need to find? We need to find the acceleration, a. So a is equal to question mark in meters per second squared. Step 3. Find the equation that has all of our variables. We have a, delta v, and t, so we can use this equation. A is equal to delta v over t. Step 4. Substitute our values into the equation. A is equal to 7 divided by 5. Now when we use the calculator, we can also enter it as a fraction by pressing this button here. To navigate to the denominator, we can use the arrow keys. If we enter it as a fraction, then it will usually give us the answer as a fraction, but we can convert that into a number by pressing this SD button here. So that gives us an answer of 1.4 meters per second squared. Question 6. A sprinter goes from rest to a top speed of 7.0 meters per second with constant acceleration. What was his average velocity in meters per second? Step 1. What variables have we been given? We have initial velocity, so Vi is equal to 0 meters per second, and final velocity Vf is equal to 7.0 meters per second. We can calculate delta V, which is equal to Vf minus Vi, so delta V equals 7 minus 0, which is 7 meters per second. Which variable do we need to find? We have been asked to find average velocity, so V average equals question mark in meters per second. Step 3. Find the equation that has all of our variables. V average is equal to delta V divided by 2. We can only use this equation if initial velocity is 0 and acceleration is constant. Step 4. Substitute our values into the equation. V average is equal to 7 divided by 2. If we put that into our calculator, 7 divided by 2, that gives us an answer of 3.5 meters per second. Question 7. A cyclist accelerates from rest at a rate of 2 meters per second squared. How fast is the cyclist moving after 4 seconds in meters per second? Step 1. What variables have we been given? We have initial velocity, so Vi equals 0 meters per second. We have acceleration, so A equals 2 meters per second squared. We have also been given time, so T equals 4 seconds. Step 2. What variable do we need to find? We want to find out how fast the cyclist is moving at the end of our time period, so that will be the final velocity, or Vf, in meters per second. Step 3. Find the equation that has all of our variables. We need to find an equation containing Vi, Vf, T, and A. We don't have one that contains all of our variables, but we do have an equation that contains delta V, T, and A. And we can calculate Vf, or final velocity, from delta V, since we already have initial velocity, by using delta V equals Vf minus Vi. So let's use this equation. We just need to rearrange it for delta V by using the triangle method. If we use the triangle method, we want A and T together and V on its own. We can see that delta V is over A and T. So delta V equals A multiplied by T. Step 4. Substitute our values into the equation. Delta V equals 2 times 4. If we put that into our calculator, we get an answer of 8. We then use the equation delta V is equal to Vf minus Vi. Vi is 0, so we can get rid of that. Our answer will be 8 meters per second. Question 8. A cyclist moving at 20 kilometers per hour comes to a stop in 4 seconds. What is the magnitude of the cyclist's average acceleration while coming to a stop in meters per second squared. Step 1. What variables have we been given? We have the initial velocity, or VI, which is equal to 20 kilometers per hour. Oh, we need to convert this into meters per second. Do you remember how to do this? We simply divided by 3.6 to give us 5.5556, and we're going to round that to 5 significant figures. Another variable we have been given is the final velocity, because we have been told the cyclist comes to a stop. So VF is equal to 0. If we have VI and VF, we can calculate delta V using VF minus VI. So delta V equals 0 minus 5.5556, which is negative 5.5556. It is a negative value because the cyclist has slowed down, or their velocity has decreased. We have also been given the time, so t equals 4 seconds. Step 2. What variable have we been asked to find? We want to find the average acceleration, or A. So A is equal to question mark in meters per second squared. Step 3. Find the equation that has all of our variables. We need to find an equation containing delta V, t, and A. We can use this equation. A equals delta V over t. Step 4. Substitute our values into the equation. A equals negative 5.5556 over 4. Let's plug that into the calculator. Negative 5.5556 divided by 4. That gives us an answer of negative 1.3888. If we round that to 2 significant figures, then our answer is negative 1.4. Question 9. A 3 kg cat jumps upward with an initial velocity of 5 meters per second. How high does it reach before stopping? In meters. Ignore the effects of air resistance and assume that g is equal to 10 meters per second squared. Step 1. What variables have we been given? We have been given mass, or m, which is equal to 3 kgs. Initial velocity, or vi, is equal to 5 meters per second. Also, we know what the final velocity, or vf, will be, since at the moment the cat reaches its highest point, its velocity will be 0. So vf equals 0 meters per second. If we have vi and vf, we can calculate the change in velocity, or delta v, which is vf minus vi. So delta v equals 0 minus 5, which is negative 5 meters per second. Gravitational acceleration, or g, is equal to 10 meters per second squared. G is simply the value of acceleration that our cat will have due to gravity, so we can also say A is equal to 10 meters per second squared. Also in this example, the direction of gravitational acceleration will be in the opposite direction to the velocity of the cat, causing it to slow down, which means that the value should be negative. So A will be equal to negative 10 meters per second squared. Step 2. What variable have we been asked to find? We want to find the height, or the vertical distance. So d is equal to question mark in meters. Step 3. Find the equation that has all of our variables. In this question, we have been given mass, but we actually don't need it. It is a red herring. So the variables that we really need in our equation are vi, vf, a, and d. The equation that we'll use is d equals vf squared minus vi squared over 2a. These equations are advanced rearrangements which make your life a lot easier by avoiding the need to do multiple steps. Now all of this may be confusing, but if you keep doing these questions, you will start to develop a feeling for how this all works. Remember that it's normal to struggle at first. That mental exertion is what it feels like to improve. Step 4. Substitute our values into the equation. D equals 0 squared minus 5 squared divided by 2 times negative 10. Let's put that into the calculator. Use the fraction button, then enter 0 squared minus 5 squared, then press the arrow key down or right to go to the denominator, and enter 2 times negative 10. Then press the SD button to convert into a number. That gives us 1.25. If we round it to two significant figures, then we get an answer of 1.3 meters. Question 10. A ball is thrown vertically upward 15 meters per second. How long does it take to reach the highest point in seconds? Ignore the effects of air resistance and assume that g is equal to 10 meters per second squared. Step 1. What variables have we been given? We have been given an initial velocity, or vi, of 15. The final velocity, or vf, will be 0, because at the moment the ball reached its highest point, its velocity will be 0. Since we have both vi and vf, we can calculate the change in velocity, or delta v. Delta v equals vf minus vi, or 0 minus 15, which is equal to negative 15 meters per second. Gravitational acceleration, or g, is equal to 10 meters per second squared. We can just use the symbol a for this. And because it will be in the opposite direction to the velocity of the ball, causing it to slow down, the value of acceleration will be negative. So a is equal to negative 10 meters per second squared. Step 2. What variable have we been asked to find? We need to find time, or t, in seconds. So t is equal to question mark in seconds. Step 3. Find the equation that has all of our variables. We want the equation that has delta v, a, and t. We'll use this equation that we used earlier and rearrange it for t. Step 4. Substitute our values into the equation. T equals negative 15 divided by negative 10. If we put that into the calculator, that gives us a result of 1.5. Question 11. A projectile is launched from ground level at an angle of 60 degrees from horizontal, with an initial speed of 20 meters per second. What is the maximum height reached by the projectile in meters? Step 1. What variables have we been given? We have an initial velocity of 20 meters per second that is angled 60 degrees from horizontal. Now, whenever we have a problem like this with an angle, I recommend drawing it out and separating the velocity into its vertical component and horizontal component. This will make it much easier to work with. Let's draw the initial velocity vector. It will have a magnitude of 20, and it will be angled 60 degrees from our horizontal line. Because we just want to find the maximum height, or the vertical distance in our question, we just need to find the vertical component of the initial velocity. For this question, we don't care about the horizontal component. You'll find a question requiring both horizontal and vertical components in the Advanced Mechanics section. To find the vertical component of the initial velocity vector, we can turn this into a triangle and use trigonometry. The initial velocity vector will be the hypotenuse, and the vertical side of the triangle will represent the vertical component of our initial velocity. The initial velocity vector will be the hypotenuse, and the vertical side of the triangle will represent the vertical component of our initial velocity, or Vyi. And the horizontal side of the triangle will represent the horizontal component of the initial velocity, or Vxi. Vy is opposite to the corner where the angle is known. So we have the hypotenuse h, and we want to find the opposite O. We need to find the SOHCAHTOA equation that contains O and h. That would be so. The equation that we use is sine of theta, which is the angle, is equal to the opposite over the hypotenuse. We need to rearrange for opposite, which represents the vertical component of our initial velocity, Vyi. We can do this by multiplying both sides by hypotenuse to get opposite on its own. So the new equation is opposite equals hypotenuse times sine of theta. Before you do the calculation, make sure your calculator is in degrees and not radians. For PHSI191, you always want your calculator in degrees. You can check this by looking at the top of your calculator's display panel. it should always have D on it. If it has an R, it is in radians and you'll get the wrong answer. If this is the case, then press Shift, then Mode, then 3. If you enter 20 sine 60 close bracket into the calculator, you should get an answer of 17.321 rounded to 5 significant figures. This is the vertical component of our initial velocity, or VYI. When the maximum height is reached, the vertical component of velocity will be 0. Therefore, VYF is equal to 0 meters per second. Gravitational acceleration G, or we can just say A, will be equal to -10 because again, it will be acting to decrease the vertical component of the projectile's velocity. Step 2. What variable have we been asked to find? As we mentioned earlier, we want to find the height, or the vertical distance. So D equals question mark. Step 3. Find the equation that has all of our variables. We need an equation that has VI, VF, A, and D. D equals VF squared minus VI squared over 2A. We used this equation earlier for question 9. Step 4. Substitute our values into the equation. Let's plug in our values. So D will be equal to 0 squared minus 17.321 squared divided by 2 times -10. Let's plug that into our calculator. Use the fraction button. 0 squared minus 17.321 squared, then arrow down or right to go to the denominator. Then enter 2 times -10. That should give you an answer of 15 meters. Question 12. A car starts from rest and accelerates at a constant 3 meters per second squared for 8 seconds in a straight line. How far does it travel in this time, in meters? Step 1. What variables have we been given? Initial velocity VI is equal to 0 meters per second. Acceleration, or A, equals 3 meters per second squared. And time t equals 8 seconds. Step 2. What variable have we been asked to find? We want to find the distance, d, in meters. So d equals question mark in meters. Step 3. Find the equation that has all of our variables. We need an equation that contains vi, a, t, and d. This equation is d equals vi times t plus half a times t squared. Complicated, right? Well, because vi is equal to 0, we can make it simpler into d equals half at squared. Step 4. Substitute our values into the equation. Let's put in our values. D equals half times 3 times 8 squared. If we put that into our calculator, 0.5 times 3 times 8 squared, that gives us an answer of 96 meters. Congratulations! That was a long ride, but you've just finished the essential kinematics problems. Try solving these problems on your own to see if you remember how to do them. If you get stuck, you can refer back to my videos. The next section will be on dynamics. What is the frictional coefficient if it takes 10 newtons of force to move a 5 kg box? How large is the acceleration of an 800 kg car when the brakes apply a force of 5,000 newtons backwards? Find out in the next video.